All right, guys, it's finally that time. We're going to be doing proofs. And I found this sheet to be really a great tool for solving proofs. You just have to know the statement and the justification. So the statement is what you're saying is congruent, and the justification is which property are you using. All right, so let's just look at reflexive property. So when they have a common angle or side. So if you look at these two triangles, they share HJ. So we know they're congruent. So you would just simply say, here's your statement. HJ is congruent to HJ. Your justification, excuse me, reflexive property. And notice reflexive property is number one. What's number two? Vertical angles. We learned if you have a bow tie or an hourglass, you have vertical angles here and let's zoom in. That's probably not very good. So if you have a bow tie or an hourglass, we know that you have those vertical angles right here and right there. Here and here. Okay, so we've got that here. So what are we saying? What's congruent? Well, BCA is congruent to angle DCE. What's our justification? Well, our justification, and whenever you're talking about angles, they're a little bit tougher because you have to do two steps. You have to first say that those are vertical angles. And that's the definition of vertical angles because you have your bow tie in this one. Then your second step, which is nice, then you get to say that they're congruent. And that's because of this. The vertical angles are congruent. And basically how it works is if you have any of these, you write your statement, which is you're saying what is congruent, and then your justification is the proof, the thing next to the number. So like for example here, since this is an angle, two steps. Angle CBA and angle DEA are right angles. That's our statement. Our justification is, well, these marks. So definition of right angle. Then we get to say the cool part. CBA is congruent to angle DEA because of this. Right angles congruent. So again, it's the same thing each time. We actually don't use third angle theorem. You could, clearly could, if you needed to, but we don't really use it a whole lot. So let's just look at some more stuff. We're proving an angle, so two steps. F, G, J is, and, ooh, I always want to jump ahead. I get impatient, but this year I'm trying to make sure I do what the other teachers want. R, alternate interior. And the reason is definition of alternate interior. Then we get to say that they're congruent because alternate interior angles are congruent. Now, key thing here, you've got to make sure that somewhere they tell you you have parallel lines, either by the marks or somewhere in there. So again, kind of just play around with this stuff. You'll see that I've marked what's congruent. Make sure you do that on your pictures. So we're kind of just expanding on what we've been doing this week. And then remember, to prove something is congruent and it's a triangle, you have side, 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 angle, side, angle, and angle, angle, side. Remember, there's no ASS and there's no no AAA. So let's just do some quick, easy ones, and then you have some time to practice on your own. So first step, you always do. First step you always do is write your givens. So it says angle BAD is congruent to angle BCD. The reason given. Okay, so now we have proven this. You have to use your justification, and now I'm going to mark it. So BAD, that's this angle right here, and BCD, this angle right here, are congruent. Again, always, always, always write your givens. Once you have justified it using one of those properties above, then you can mark it. ADB, it's our second angle. CDB, second angle. Okay. And ultimately, what I want to do is prove this. Well, I'm trying to prove a triangle, so I'm trying to use either side, 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 angle, side, side, angle, or angle, angle, side. So really, I kind of just go through the checklist. Do they share a side? Great, they do, right here, BD. So I get to say BD is congruent to BD. And I made a blunder there. Don't mark your picture until you've justified it. How do I know this is true? Well, since they share a side, that's the reflexive property. Now I've justified it. Now I've marked it. And basically, I keep going until I have one of the four. Well, on this one, I've got angle, angle, side. So I'm done. So I get to say angle ABD is congruent to triangle CBD by angle, angle, side. Okay, let's do one more. Here we go. Okay, always, 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 always write your givens. AC is congruent to DC. Reason given. AC is congruent to CD. EC is congruent to BC. Given. EC, BC. Okay, so I kind of just go through the checklist. Do they share a side? No. Is this an hourglass or a bow tie? Yes. So that means I have vertical angles. Right here, ACB and ECB. All right, so angle ACB and angle DCE are vertical angles. Remember, whenever you're proving angles, 2 steps. Now that means these are congruent because vertical angles are congruent. I have justified it. Now I can mark it. And again, we keep going until we have one of the 4. We're done here because we have side, angle, side. What were we trying to prove? That triangle A, B, C is congruent to triangle DBC. We have done that, so we're done. Try some of these on your own. One of the sheets is much tougher than the other. I will post answer keys and video of me going through it. Your job, try it on your own, then check the videos. Have a great day, guys. I'll see you later.